So there are some good questions coming through in the chat box and the Q&A. And also, if you would like to ask the question, raise your hand and we'll keep an eye out for raised hands as well. So let's go on to the first question in the Q&A. So I think this is for Jan-Hendrik Venter. Is there any evidence of host switching of indigenous insect species from indigenous plant species to crops? And there's an example they cited here, the beetle onto sugarcane, possibly from erythrina trees. So Jan-Hendrik, can you address that question? Yeah, there's definitely evidence to that, and the reason for that is probably that when we start monocultures over large areas, we literally destroy natural ecosystems, and some of those pests are just adapting to this new crop, and it may take years for them to do that, and some do it much quicker. Some of the other examples that I can show you is well known actually. If we look at fruit flies, most of our horticultural fruit types are utilized by local fruit flies. False codling moth, for instance, is a great example. It's attacking quite a number of fruits. It's very polyphagous. But then there are others which is not polyphagous, which over time also develop, like the sugarcane, the longhorn border on sugarcane. And then and some other examples are, for instance, Pusciola fusca, which is the maize. Now that I see the maize behind you, Gabe. It's also indigenous, so it's a large problem in Africa. But maize isn't indigenous, so maize were introduced, and it's thought by itself, hey, this is a better food source for me, so let me utilize it. So insects are very adaptable. So are pathogens, and I think it's easy to recognize the insects, like a big longhorn beetle on sugar canes, which that has a great impact, but the pathogens are sometimes less looked at, and that's where I think Prof. Wingfield's work is so incredibly important, where he's built up a lot of data over a number of years. Then we get temporally switched as well. Sometimes it's drought, and then you may find something suddenly be on grapevine, for instance, some of indigenous Lepidopterus, and it may be there for a season or two, and then you don't see it ever again. Great, thank you. There's also from Jaco Marais is just saying thank you for your informative presentation, Jan-Hendrik. And then someone asked a question, it's about actually data collection. Why do we have to depend on CABI summary data? So maybe you can just tell people what CABI is, and maybe address why we are dependent on that data, and whether there's anything we can do about it here in the country. Yeah,
I used CABI as a data source. It's just easier to get a global perspective, but certainly it's not necessary to use CABI. CABI is a data collection base, basically for quite a number of different pests, and they get their data from different data sources, such as the EPO database, and that gives you some good perspective. There's a lot of mistakes, so one needs to get back to the source data to be sure that you don't make mistakes in that regard. But yes, and then also the global maps, just to give you some perspective on that. The global maps, CABI is only country based, so once there's one detection in a country, the whole country will be colored in the map. So
It's not point data. So, and point data maps are more difficult to obtain because you have to rely then on publications and then collaborate them or add them together and make your own map. The issue is that many countries don't want to reveal those point data as such. And that is where, on a global level, that is important for horizon scanning. It is actually meaningless to see a country has got now this pest. What is important is to see the specific point data as in terms of climatic conditions, host availability, population, the approximation to ports of entry and cities. To give you an idea, is that in the last couple of years, some of these subtropical fruit flies or tropical fruit flies actually have been detected in Vienna. And Vienna is not a really tropical area. It's quite cold there. So they cannot survive in Vienna. But why were they detected in Vienna is a question. And they are detected in more than one species in different surveillance traps. They are detected in summer, but they are detected close proximity to fruit vendors. So it's an infested material that came in. The pest pupate, if adults came out, they might have mated, we don't know, and they find themselves in a surveillance trap. Comes winter, the population dies out again. So those things are important to note, but and that's why you need to go back to the original publications of all of these.
Okay, great, thanks, Jan-Hendrik. Prof. Mike Wingfield says, thanks for a very useful talk. Jan-Hendrik, also to you and your team in dealing positively with a very challenging and important problem. This appreciated to be assured of our support where this can be helpful. And maybe I can follow that question up with asking your opinion about the role of citizen science in actually dealing with these biosecurity threats. Do you have any ideas on citizen science? And maybe Professor Crew can also give his opinion on whether the honeybee situation, is there any role that citizen science can play in these issues?
Yeah, worldwide, I think that is getting more and more important. Governments have to rely on citizens to assist with certain, especially pest detection. I think if no one knows better than the local community of new things entering the area. And that is still a bit lacking in South Africa. I must say that we don't have good communication channels and good capacity building for citizens. I know years back there was in Australia, for instance, some educational programs which starts at school grades, in the lower grades, to do in terms of plant quarantine aspects. And that works a lot, because now their awareness systems are of such a nature. The public reports regularly new sightings. We know there's a company in South Africa, Cropwatch Africa, who has developed an application which is called Biosecurity Africa, and they've got a sighting thing on it. So anyone, it's a freeware app, so anyone can report a sighting there. And those sightings, then I've got access to the data of that government, so it's very nice of them to do that. Most people ask money, but obviously that is maybe temporary. I don't know, but the point is that that is one initiative which is incredibly important, and we need to roll it out maybe a bit more, which will help us then also to get these things early. Because now we can take a photograph, and I think we are trending on your expertise, Dave, but you can take a photograph and then send it through the app, anyone from the public, and it makes it just much easier for us to notify things, to be notified. Taking that into perspective is that we also need then to build the capacity on this side to receive all of that information. So that's not always the easiest thing, and to respond to that. So those measures must be put in place. And in the end of my slide, I talked about a public-private partnership deal. And if one look at the model that the Australian government has followed by creating Plant Health Australia, basically all the actions, operational activities lies within industry. and also the public, where the government is doing the regulatory aspects. So what happens then, surveys, reporting, all of that is managed by industry, which is much easier then for government to respond, because basically the response is already done. And that's maybe one of the areas which we need to build.
Great.
The other important thing in Australia is to mention that what Australia does, that they've created that fund, and that fund is managed by the industry, not by the government, which may be particularly important also for South Africa.
Great. Thanks, Jan-Hendrik. You just introduced my talk very nicely. Thank you very much. So, Professor, comment on the role of citizen science in the honeybee industry, pollination services.
Yeah, thanks, Dave. I think that there's been an upsurge in amateur beekeeping. Whether that falls into the domain of citizen science or not, I'm not sure. But it certainly is the case in Europe and North America that there's been an upsurge in amateur beekeeping, where people keep 1 or 2 colonies on their balcony or something of that kind. And they even plant flowers to allow the bees to forage in them. So from that point of view, it's been important, and it's important for establishing a lobby that which can assist us with protecting these species that are so important. In Africa, amateur beekeeping is more of a challenge because our bees are substantially more defensive. And so it's not for the faint-hearted. And there's also legislation in most of the cities which prevents you from keeping bees on plots that are smaller than a certain size and so on. And that's because of the potential danger of the bees. But there's a second important aspect of citizen science, which is the keeping of bee hotels. That's a strongly developing activity at the moment, both here and in other parts of the world. And a bee hotel is essentially a block of wood with a number of holes of different sizes drilled into it. And this allows for the nesting of solitary and subsocial bees, which form the majority of the species that we have. And so where these activities can be organized and the bees identified, it gives us a significant amount of information about biodiversity and changes in abundance over different seasons. Just to give you an example, in South Africa, there are roughly just over 2,000 species of bees. So these bees hotels may actually give us some significant information about those lesser known but very important species. Thank you.
Great, thank you very much. And I actually got a bee hotel for my birthday, so so you can get them in Pretoria. So I encourage people to put them up in their gardens. So that's great. We're still waiting for the spring for something to get in there. But we'd be happy to.
You'll also get wasps, of course, because they're wasp parasites of those bees. So your bee hotels turn out to be a very interesting ecosystem that you can look at.
Great, thank you. Okay, so a couple more questions here. There's one about naming of organisms in policy. So one of the biggest challenges we have in working, particularly with microbial pathogens, is dealing with host-specific genotypes, as opposed to the largely taxon name based on quarantine procedures. I don't have an easy answer to this question, but wonder if you have some thoughts. I think that's from Professor Wingfield.
Yes, no, it's actually in terms of regulation, just to start there, it is and regulatory actions, that is a nightmare. So we would like to be very sure that when we pose legislation that we've got the right, first of all, the right identification of a pest or pathogen, but then also that we've got the right host. So we can't regulate, for instance, for importation, the host, which is not really the host. So that puts us in a legal dilemma. So my thoughts are, yes, this is certainly science that needs to be promoted. And I think it's from the last talks that I had with Prof. Wingfield over the last month, it's incredible how far we are with that. But it does give us problems in terms of a database like CABI, which would then tend to only have broad-based type of collections. I must say that that is changing. There's you just a couple of years ago, for instance, you would have Fusarium oxysporum, and then South Africa has got it, but it doesn't really distinguish between the different races. Now they have a specific page for Fusarium oxysporum tropical race 4, which is significant improvement. Otherwise, South Africa would have been included in the mix. They did the same with citrus greening to start to distinguish between the strains. So there are some improvement, but we know there's a lot of work that still needs to be done on these. The problem with these type of internationally accessible databases are that the one pulls information from the other. So you tend up in a rotational cycle. So you get the EPO goes to this site and this site goes to EPO, just for an example. And then you tend to rectify something on the database, and then the other one is using old data again, and then it pops up again after a year or so. So there's drawbacks on that, but certainly scientific publications emanating from these type of research are incredibly important, because that is our tool. So to veto these type of broad-based databases, to say, but hang on, we've got a publication that says otherwise.
Great, thank you. That's not an easy one to answer, but I think that shows that we need really good communication between the scientists who are really looking at the fine detail and policymakers such as yourself. I think we're getting close to the end of this session, but I'll give maybe one last question to each of you. So, Professor Crew, it's not exactly the topic, but could you maybe tell us a little bit about the problem of adulteration in honey production and honey sales in South Africa specifically? I know you're on a panel or advisory body as far as that's concerned. So can you share just some insights on that?
Yeah, I mean, I think that honey adulteration is related to the fact that very often various kinds of sugar syrups are added to honey in order to increase its bulk. So that you sell a product that's called honey, but the amount of honey in that product may be relatively low, of the order of about 10%, let's say. So it's really not honey. It's either rice sugar or some other kind of sugar syrup which is being sold as honey. That's the most prevalent example of honey fraud. But there are other examples of honey fraud, such as what I call honey laundering, which is that you have countries that produce bulk quantities of honey and then export them to another country. And then that country exports that honey as though it was originating from that second country. And that's essentially honey laundering. And the objective of that is to, of course, raise the price of the product. because honey from particular countries has higher value than from others. And so those are some of the major issues that need to be dealt with. And I think some of the new molecular techniques which allow us to analyze whether the honey actually ever passed through a bee or not is helping to detect some of the fraudulent activity. And we're also getting more sophisticated at identifying the floral sources. So the claims of producing Manuka honey, for instance, which is very high value, can be checked by seeing whether there's any Manuka DNA in the honey to substantiate the claim and what the proportion is. So it's an arms race between the fraudulent producers of honey and the forensic investigators who are attempting to use ever more sophisticated methods of actually detecting them. Thanks, Dave.
Great, thanks very much. Fascinating. I think we'll have to end the session here. I see Janci is back, and it's been a super session. Thank you for both of you for fascinating insights, and there's lots more to talk on these topics. So Janci, shall I get back to you so you can hand on to Professor Wynand-Swart?